guys, good evening. How are you? Well, it's been a very long time since I recorded a video, and so today I bring you the video on DNS. We're going to be talking about domain name system, how it functions, and then its importance in the networking and server environment. Now, DNS stands for domain name system, and it performs a very important function on TCP/IP based networks. It resolves host names such as www.louis.com to IP addresses such as 192.168.1.1. Now, whenever computers are set up in networking environment, for them to be able to communicate amongst themselves, the computer needs to be given an identity. Now, this identity usually is an IP address. Now, it will be very difficult for people to remember IP addresses. So instead of we using the IP addresses to access these computers or servers such as our Facebook, Yahoo, Gmail, any of these locations, they rather set up this system called DNS. Look at DNS like your address book. When you take your address book, usually whenever you want to call someone, you look at their names. But then whenever you want to call someone, it is not the name that you are calling, rather the number that is associated with the name that you are calling. So when you type www.facebook.com, www.google.com, or whatever address that you're trying to visit, then DNS has a database just like your address book. So it takes a look at this database and then it's able to say, okay, facebook.com maps to this particular IP address, and then it forwards the information there. Now, because of DNS, it is possible for people to remember the names and refer to the frequently used hosts using easy to remember host names rather than the hard to remember IP addresses. So DNS stands for domain name system, and its function or purpose is to make sure that you can remember the names or the domain names or the host names, and then when you type the domain name or the host name, the DNS will resolve it or point it to the IP address, which is the actual name of the system. DNS components. Now, there are three main components for DNS to function. First, we have the DNS server, then we have the DNS database, and then the DNS client. The DNS server is the server that holds the DNS service or the DNS role. So for DNS to function, a role needs to be installed on the server that tells the server what it's supposed to do. Now, when the role is installed, a database is created. The DNS database is basically a list of domain names and their corresponding IP addresses. Now, if you have the server that is hosting the DNS database, then this server is the server that is going to resolve the client request. So the client is basically the system that queries or requests name resolution from the DNS server. So the DNS components, we have the DNS server, the DNS database, and then the DNS client. Now, DNS works in what we call the DNS name space. Now, the DNS namespace has logical divisions that is organized in a hierarchy. It has logical divisions that is organized in a hierarchy. Now, at the very top, we have the root servers. Now, the root server normally is represented by a dot, which comes after the top level domain name. Top level domain names are usually the .com for commercial services, .edu for education, .mil for military, .co.uk country specific. Then we have below the top level domain, we have the subdomains. The subdomain or the second level domains, and these are associated with the organization or commercial companies. So when you take a fully qualified domain name like www.google.com, then the top level domain name is .com. Then the subdomain or the sub-level or second level domain name is the one that is related to the organization. In this case, we can say Google. Then we have the host name. The host name usually will be the www or probably pc1.google.com or pc2.louis.com. That is the host name that uniquely identifies the particular system that you are looking for. So when you have a domain name along with the subdomain and the top level domain name, all these come into play. This is referred to as a fully qualified domain name. So sometimes you can define DNS as the system that resolves fully qualified domain names to IP addresses. Now, let's talk about DNS queries. Now, when we say a DNS query, a query is basically a request for name resolution that is directed to a DNS server. So, for example, you type www.google.com and you hit enter. You are querying a DNS server, because when you look at the IP configuration of your system, you're going to have the IP address, then there's going to be a subnet mask, there will be a default gateway, then there's going to be preferred DNS address. So one way or the other, there's going to be a DNS address there. So when you type any address and then you hit enter, what you are doing is you are querying a DNS server. Now we have two types of DNS queries. We have the iterative query and then we have the recursive query. Now when a DNS server is configured to be iterative, or when a DNS query is iterative, then what it means is that the DNS server does not forward the query to another server if it does not know or does not have the information. So when you type www.google.com and your DNS server does not have it, then the DNS server is not going to forward the information to a different DNS server. Immediately it's going to give you a feedback that web page could not be found or the server could not be located. Then if the query is recursive, then what it means is that if this DNS server does not know or does not have the record, then it's going to forward the query to another DNS server that might be able to resolve the information, So we are going to pause this video here. In the next video, we are going to talk about authoritative server and the non-authoritative servers. Then we'll look at DNS zones, and then we'll look at DNS forwarders. I don't want the video to be lengthy, so it will bore you. So I'm going to see you in the next video. Thank you for watching. Subscribe, share with your friends.